Today's topic is Introduction to Acid and Bases. We're going to learn about different acid-base theory. I would highly recommend you to have your handout, the one that it was given to you in Google Classroom. Have it out. Make sure if you haven't downloaded it, make sure you download the file so that you can follow the notes. Our objective for today's lesson is to identify acids and bases based on both theories. We're going to talk about Arrhenius theory and the alternate theory. We also have to recognize the properties of acid and bases. Acids. Acids were first recognized as substances that taste sour. Vinegar tastes sour because it is a dilute solution of acetic acid. Citric acid is responsible for the sour taste of a lemon. Bases, sometimes called alkalis, are characterized by their bitter taste and slippery feel. Most hand soaps and commercial preparations for unclogging drains are highly basic. The first person to recognize the essential nature of acid and bases was Arrhenius. On the basis of his experiments with electrolytes, which we learned in our last lesson, Arrhenius suggested that acids produce hydrogen ions in an aqueous solution, where bases produce hydroxide ions. Although the Arrhenius concept of acid and bases was a major step forward in understanding acid-base chemistry, this concept is limited because it allows for only one kind of base, the hydroxide ion. A more general definition of acid and bases was suggested by the Danish chemist Brønsted and the English chemist Lowry. In the Brønsted-Lowry model, an acid is a proton donor and the base is a proton acceptor. According to the Brønsted-Lowry model, the general reaction that occurs when an acid is dissolved in water can be best represented as an acid donating a proton to a water molecule to form a new acid and a new base, which we are going to learn more about it as we move forward. So, what is an acid? According to Arrhenius theory, acid is a substance that produces H plus ion or H3O plus ion, which happens to be known as hydronium ion, in an aqueous solution. So you need to know that according to Arrhenius theory, acid is a substance that produces hydronium ion. According to the alternate theory, which happens to be known as Brønsted-Lowry theory, also known as one acid-base theory, you need to know that acid donates proton. So acid is the proton donor. Common binary acids can be found in reference table K. In table K, you will find most of the common acids, and if you notice carefully, all of the acids have hydrogen. The first acid that is listed in reference table K is HCl. The name of HCl is hydrochloric acid. So the way hydrochloric acid, in this case, it's formed is basically you have hydrogen, which is attached to a group 17 halogen. And halogens are fluorine, chlorine, bromine, and iodine. So in this case, they gave you an example of HCl, which happens to be an acid. You need to know that HF, HCl, HBr, and HI is also going to be an acid. Now, this part is listed in your handout that was given to you based on Google Classroom. I wrote the topic acid and I gave you all the definitions of acid based on Arrhenius and alternate theory. I also wrote down some common acids for you And also, please make sure, don't forget to look back at reference table K. We're going to talk about properties of acids. And as we talk about those properties, it is good for you to write down those properties and review them later. You're going to be answering a bunch of questions related to this topic. Properties of an acid. The first thing we need to know that acids are electrolytes. And again, electrolytes are ions that are soluble in water which can conduct electricity. Remember, review your previous lesson on electrolytes. Based on our previous lesson, we should know that ionic substances, acids, and bases are electrolytes. Now, we also need to know that acids react with certain metals to produce hydrogen gas. Only copper, silver, and gold cannot react with an acid to produce hydrogen gas. If you look at reference table J, there are two columns, one for metals and the other one is for non-metal. And in the column of metal, you can see that we have hydrogen gas. Hydrogen is not a metal. So why is it listed in the table for metal? Now, the reason it is listed in our reference table, J, in the column for metal, is because you need to know that copper, silver, and gold, the three elements that are under your hydrogen gas, they cannot react with an acid to produce hydrogen gas. Anything above hydrogen in the column of metals, they can react with an acid to produce hydrogen gas. Again, copper, silver, and gold cannot react with an acid to produce hydrogen gas. So usually when we have one of these metals, for example, lithium, sodium, magnesium, any metal that are listed above hydrogen, we can have them react with an acid and you will see bubbles, and those bubbles are basically hydrogen gas. More properties of an acid. Acid turns litmus paper red. So if you have a litmus paper right here, if you're looking at a litmus paper, if you place that litmus paper in an acid, it will turn slightly red. Then we have to talk about neutralization reaction. Neutralization reaction is a reaction between acid and bases. And in that reaction, acid will react with the base to produce salt and water. These are the properties of an acid we need to know for our Regents exam. Now, so far we talked about acid, now we're going to talk about base. Arrhenius theory of a base. Base is the substance that produces hydroxide ion in an aqueous solution. So if you look at reference table E, you'll find OH minus, which is hydroxide ion, and you should memorize the polyatomic ion, which is hydroxide, because you need to know that if a substance, we're recognizing a substance as a base, according to the Arrhenius theory, it should produce hydroxide ion in an aqueous solution. However, based on alternate theory, or Bronsted-Lowry theory, there are bases which might not produce hydroxide ion. Instead, they are going to accept the proton that was donated by the acid. So according to the Bronsted-Lowry theory, we knew that acids were proton donor. So if acid is donating proton, base most probably going to accept that proton. So we need to be aware of both theories. So let me review Arrhenius theory first. According to Arrhenius theory, acids produce hydronium ion and bases are going to produce hydroxide ion. The alternate theory, which is Bronsted-Lowry theory, is acids are proton donor and bases are proton acceptor. Now, you most probably are going to be overwhelmed with the theory of Arrhenius and alternate theory. But at the end of the day, a substance, if it's an acid, it will be an acid based on both theories. If it's a base, it has to be a base based on both theories. The theory might seem different, but they're not that different at all. Now, please don't forget to look at your notes that were given to you in our Google Classroom website. In that note packet, you have the Arrhenius theory and the alternate theory for a base. Common bases are listed in reference table L, and we're going to talk more about it as we go forward. We also need to talk about properties of bases. Common bases. If you look at your reference table L, you're most probably going to realize that bases, most of them have OH. And that's because according to Arrhenius theory, bases are going to produce hydroxide ion, which is OH minus ion. So the most common bases are when you have a group 1 element with the hydroxide ion. For example, sodium hydroxide. Sodium is from group 1 attached with the polyatomic ion of hydroxide, and together it forms sodium hydroxide. Another common base would be elements from group 2 with hydroxide ion. For example, calcium hydroxide. So you have calcium, which is from group 2, bonded with the hydroxide ion, which is a polyatomic ion, and together they form a base. Now, you can look at the example that was given to you over here as well. Lithium plus 1. If you look at the oxidation state number of lithium on the top right corner from page 9, it's plus 1. And if you look at the polyatomic ion from table E, OH is minus 1. So together they form lithium hydroxide, which is going to be a base. We have magnesium from group 2. The oxidation state number is plus 2. Again, please look at page 9, top right corner from your reference table. And then hydroxide can be found in table E for polyatomic ions. And we have magnesium plus 2 and OH minus 1. So the ratio is 2 to 1. So you need 2 hydroxide for each magnesium. And this is the reason we have magnesium hydroxide, and you have 2 of them. A common mistake is where students usually write MgOH. This is not correct because you need 2 hydroxide ions for each magnesium ion. Let's talk about properties of bases. Bases are also electrolytes. So again, one of the misconceptions that students have is they assume acids are electrolytes and therefore bases are non-electrolytes, which is not true. Bases are electrolytes just like an acid. The difference is acid turns litmus paper red, but bases are going to turn litmus paper blue. One easy way to remember this is bases are blue. And you need to know that most common bases are listed in reference table L. So if you have to answer a question regarding electrolytes during a Regents exam, it is wise for you to look at reference table K and L because you should know that acid and bases are both electrolytes. So we are going to talk briefly about weak acid and bases in terms of Regents exam. We're not going to talk about it in depth. One thing you need to know is NH3, the last one from table L, is a weak base. And to keep things simple and straightforward, just remember that the last one from table K is your weak acid. Carbonic acid is also a weak acid, but again, as I said before, we're not going in depth to talk about strong and weak acids or bases. Just remember that the last one from both reference table are an example of your weak acid and a weak base. Now we're going to focus on your notes. We're going to talk more about net ionic equations and amphoteric substance. So please follow your notes because these notes are already in your packet, the one that is given to you. So feel free to take additional notes as we go forward. Net ionic equations. Before we understand net ionic equation, we have to understand neutralization reaction first. If you focus on the word neutralization, it sounds like neutral. So in an acid and base reaction, we're producing salt and water. Both acids and bases are extreme, but we are forming something that is normal, water, neutral. So in a neutralization reaction, easiest way to remember is you're using two extremes to form water, which is neutral. In this example, we have HCl, which is an acid. You can find it in reference table K. NaOH, which is a base. You can find it in reference table L. Produce salt, table salt in this case, which is NaCl, and water. Again, just a quick review. In chemistry, we call ionic substances as salt. So it's not just NaCl, it could be any ionic substance. Now, let's talk more about neutralization reaction based on the reaction that we just talked about. If you notice HCl, the phase is aqueous. That means it is in aqua or it's in water. When you have acid HCl in water, it breaks apart into H plus and Cl minus into ions. Same goes for NaOH, which is a base. When you have NaOH in water, it breaks apart into sodium ion and hydroxide ion. And this is the reason they are electrolytes, because they form ions in water in a solution that can conduct electricity. And they will react with each other to produce water, which is in liquid phase. You can focus on the phase for each of them, and you'll realize that we form something different over here. So what is the net ionic equation of all acid-base reactions? Meaning something that changed. So in this case, Cl minus, I have it on my left side, and Cl minus, I have it on my right side. So it did not change. We have Na plus on my left side and Na plus on my right side. But you can notice that H plus from my left side and OH minus from my left side, right? These two changed and form something new, which is water, a covalent substance. So we had two different ions forming H2O, which has a different phase. And that's our net ionic equation. We're also going to talk about amphoteric substance. A common example of an amphoteric substance is water. Basically, amphoteric substance is a substance that can act as an acid, and sometimes it also acts as a base. There are other examples of amphoteric substance, but we're going to focus mainly on water. So again, water is a substance that sometimes acts like an acid and sometimes it acts like a base. So we have to figure out if it's an acid or a base when it appears to be in an acid-base reaction. Let's take a look at this example. We have HCl on our left side, and we have H2O, water, on our left side. Now, what exactly happened with HCl from our left side to our right side? So here we had HCl. On our right side, it became just Cl minus. What just happened? Based on my understanding, and I'm not trying to think in terms of chemistry, in this case, I noticed that I'm missing the letter H. Before I had HCl on my left side, now I just have Cl on my right side. So I'm missing the letter H. In terms of chemistry, that means I'm missing H plus ion. So that means HCl donated H plus ion. And if HCl is donating H plus ion, that means in this case, HCl is an acid. Now, let's focus on water. What happens to water? We had two hydrogen and one oxygen. And what happened to water afterwards? After this reaction, after this arrow sign, now I have three hydrogen with one oxygen and a positive sign. If we don't think in terms of chemistry, we can ask ourselves a question: what happened to H2O from my left side to my right side? And if I'm not thinking in terms of chemistry, I can figure out that now on my right side, I have an additional H. So let's bring chemistry into it. So here, on my left side, I had water, but on my right side, I have an additional H with a positive sign. That means this water molecule gained an H plus ion. So what usually accepts or gains H plus? Based on alternate theory, or based on Bronsted-Lowry theory, or based on one acid-base theory, water, in this case, in this specific example, water is a base which accepted the H plus ion or the proton from the acid, which happens to be HCl in this question. So if you're looking at the Regents question, according to one acid-base theory, water acts as, in this case, water is acting as a base. So I should eliminate option 3 and option 4. And if it's a base, what just happened? It is accepting an H plus ion. It's not donating, it is accepting an H plus ion. So you're going to have an online assignment where you have to answer questions from your packet that I gave you on Google Classroom. There are multiple questions that will help you to understand and test your understanding on the acid-base theory, the properties of acid and bases. So please make sure you complete the online assignments. There is another additional assignment going to be on neutralization reaction. And we are going to talk more about neutralization reaction in our next lesson. So till then, please make sure you complete the online assignments on electrolytes, and then you complete the online assignment on acid-base theory. In our next lesson, we're going to talk more about neutralization reaction. Remember, if you have questions, please write them down. Ask me during the tutoring hours, or send me an email. I will try my best to help you as best as I can. Thank you.